Good morning all. Welcome back to our course on the C programming language. In today's session, I am planning to discuss on the type conversions. So, by looking at the title itself, you can observe that this is something related to converting of types. So, we have seen different data types in the C programming language. A data type specifies what type of data you are going to deal with and what is the size of each and every data which you are going to store. All these things you know very well, right. So, we have different data types that are supported in C like int, char, float, double, etc. So, the meaning of this title is we are going to convert one data type into another data type. This particular terminology can be modified and we can also call it as type casting. So, type casting is similar to that of type conversion, they are used interchangeably, right. So, if somebody asks you what is type casting, it is nothing but type conversion. So, by the name itself you can say that you are going to convert one data type into another data type. The C programming language supports two types of typecasting. One is called as the implicit typecasting and the second one is called as the explicit typecasting. The implicit typecasting means the compiler will automatically convert the one type of data type into another type of data type. So, it is the conversion of one data type to another data type will be taken care by the compiler itself. But coming to this explicit typecasting, it says that it is not the compiler who converts one data type into another data type. The programmer, here the compiler will take care of everything, but here the programmer has to explicitly force the compiler to convert one data type into another data type. Here in the explicit typecasting, we make use of an operator called as the cast operator or casting operator, anything you can call. But implicit typecasting does not require any operator for its conversion. Why? Because the compiler will be taking care of everything. It will convert the lower data types into higher data types automatically. So, in the implicit typecasting, the lower order data types are converted to higher order data types. What do you mean by lower data types and higher data types? It is based on the size. For example, if you take the size of char, it takes 1 byte. Similarly, integer is considered to be, it takes 4 bytes of data, and then float also 4 bytes, and then we have 8 bytes. So, the lower order data type means character will come into the first place and then integer and then we have float and then we have double. In between these we have some other data types like unsigned, signed. We have discussed everything while discussing the data types in C. So, signed integer, unsigned integer. Signed integer in the sense it is capable of storing both the positive as well as the negative values. Unsigned integer means it is capable of storing only positive values. Like that we can have unsigned char, we can have signed char. So, in the implicit typecasting, the lower data types will be automatically converted to the higher data types by the compiler itself. But in the explicit typecasting or type conversion, the programmer has to force the compiler, to convert one data type into another data type. So, while forcing the compiler to convert the data types into different things, you can convert the higher to lower as well as lower to higher. So, when you are going for lower data type to higher data type conversion, no need to specify it explicitly. Why? Because the compiler will automatically convert it. We will see with few examples in this session. But while you convert the higher order data types to lower order data types, you should be very careful that some of the data will be missing when you are converting the higher data types into lower data types. This is the overview of the type conversions that are available in the C programming language. Let us go with the discussions. So, type conversion is a method that is used in the C programming language, where you can convert one data type into another data type. That is the actual meaning of the type conversion, the actual definition of the type conversion. Here the operands of a binary operator must have the same data type, and the result is also of same data type. We will see with examples, right. So, this is the formula to convert the Fahrenheit into Celsius degrees. So, you will be given a value of temperature in the Fahrenheit, and if you are asked to convert it into the centigrade, this is the formula we are going to use. C is equal to 9 by f multiplied with f minus 32. Here you can see that 9 is an integer. Why? Because it does not have any decimal value. Similarly, 5 is also an integer and 32 is an integer. So, if you take the f and c value as integers, the result will be an integer. Here you can see that 9 by 5, this integer divided by integer. So, the result will be integer only. But the same formula, if you convert it into the floating point manipulations. So, you can see here that 9.0 is taken as the floating point value. Similarly, 5.0 is also taken as the floating point value. So, floating point value divided with the floating point value, we will get the floating point. But remember, it also depends on the LHS variable also. So, if C is taken as float, the result will be, the end result will be float. But if C is taken as integer, the end result will be integer. That means that decimal values will be automatically truncated. They are completely removed. For example, if I get the value as 32.567, the end result, I am saying about the end result. If C is a floating point value, or if it is a floating point value, then you will get the display as 32.567000. Why? Because the precision of float is 6 digits. But if you consider the C as integer, what happens here? The decimal values will be completely truncated. So, the result what you will get will be 32 like this. So, this is what is going to happen. As I told in the earlier discussion, that when the higher order data types are converted into the lower order data types, then you may lose some data. So, you are in this particular example, you are losing the precision here. Right. Similarly, for example, if you take the same formula for calculating the Celsius using the Fahrenheit, see here this one. 9.0 is a float value and 5 is considered as an integer value. A float divided with the integer, that means integer is lower order and float is higher order. If an expression consists of the lower order and the higher order operators or operands, then the lower order operands will be automatically converted to the higher order operands. This is called automatic typecasting, or it is also called as implicit typecasting. So, this is a very good example where an expression consists of a mixed values of floating and integer. The end result will be the higher order data type. So, if you have float and integer, the integer is automatically converted to float and the entire result will be float. But if you consider this LHS, If C is integer, you will get the integer value, and if C is float, you will get the float value. This is called as the automatic typecasting or implicit typecasting. There exists another typecasting mechanism which is called as explicit typecasting, where I told that the programmer has to explicitly force the compiler to convert one data type into another data type. This is called as forcible typecasting, or we can also say it as explicit typecasting. For example, you take the same formula here, C is equal to 9 by 5 multiplied with f minus 32. Here 9 is integer and 5 is also integer. The end result of this expression 9 by 5 will be an integer. But if you observe this particular formula carefully, you can see that I am using a special syntax here before 9. The special syntax is a very simple syntax where I am using the parenthesis, and within the parenthesis I am just placing a data type float. So, this is called as the cast operator. I told you in the earlier slide. For explicit typecasting, you have to force the compiler to convert it into the required data type. So, the required data type is specified inside the parenthesis, and the entire parenthesis plus this operator or the data type is called as the cast operator. So, when you precede this cast operator before an operand, initially 9 is an integer, but before this I have float. I have used a cast operator called float. By looking at this cast operator, the compiler, what it will come to know is, it will come to know that, oh, the user is asking me to convert this integer data type of 9 into the floating point data type. So, this entire expression will be converted into 9.0 divided by 5 into f minus 32. This is what happens here. So, a float divided by integer, we know that by implicit typecasting, the lower order data types will be automatically converted to higher order data types. So, the result will be float. So, remember that while implicit typecasting, there is nothing to be done by the programmer. The compiler will automatically take care of everything. But in the explicit typecasting, you have to specify, you means the programmer has to specify the data type which he wants to convert it into. That is done by making use of the cast operator. Specifying a cast operator is very simple. Its syntax is, you have to make use of the parenthesis, and within the parenthesis you have to specify the data type to which you want to convert. For example, if you want to convert it into double, so what I can do here, I take the parenthesis, and within the parenthesis I put my data type as double. That is it, very simple conversion. So, let us see some of the examples here. In the automatic typecasting, which is also called as the implicit typecasting, this is the hierarchy it is going to follow from lower order to higher order. See here, this char and short char will be automatically converted to int. So, if you have an expression that consists of both long and int, the result will be automatically converted to long, and if it consists of long and float, the result will be automatically converted to float. Float and double, the end result will be double. If you have an expression that consists of double, float and long, the lower order data types will be automatically converted to higher order data types, therefore, the end result will be double. So, like that the hierarchy will be taken for conversion of the lower data types into higher data types. That is what he is saying. So, char and short operands are converted to integer, lower order data types are converted to the higher order data types, and the result will be of higher order data type. This is what I am stressing from the starting point, right. And the conversions between the unsigned and signed, very important point. So, unsigned means it is going to store only positive values. So, one bit of data will not be assigned for storing the sign, whether it is positive or negative. But in the signed data types, we know that it is going to store both the positive values as well as the negative values. For this purpose, we are allocating the leftmost bit or the most significant bit to be used for specifying the sign, that is whether it is positive or negative. 1 represents negative, 0 represents positive. So, this is the difference we have between the unsigned and signed integers. But when you are converting the unsigned to signed or signed to unsigned, the results is unpredictable. So, you will get some vague results which you cannot predict. Here he is giving some examples like f is a floating point variable, d is a double variable and long is a double variable, and I is integer, s is short. D plus f, d stands for double and f stands for float. So, the lower order float will be automatically converted to double. So, the result will be double here. Similarly, I by s, integer divided by short, short will be converted to int. L by I, this is an expression consisting of two data types, long and int. So, integer being the lower order data type, it will be automatically converted to long data type. So, the result will be long. These are the few things you need to understand about the explicit typecasting. The general form of a typecasting operator is I told right. So, this is the typecasting operator. Before the expression or before a variable or before a value or a constant, you specify the data type to which you want to convert that expression in the parenthesis like this. This is the syntax we have. And remember that it is generally a very good practice to use the explicit casts than to depend on the implicit typecasting. So, do not ever rely completely on the compiler for this typecasting concepts. It is better that you explicitly specify the data using the casting operator to which you are explicitly specifying to which data type you want to convert. This will be a good choice rather than purely depending on the implicit typecasting. This example we have seen in the earlier slide, right. So, 9 is an integer, 5 is an integer, but here I have typecasted, explicit typecasted this 9 constant value to float. So, this will be taken as 9.0. 9.0 divided by 5, it is automatically converted into float. And here are some of the disadvantages we have when we convert the higher order data types into lower order data types. For example, if I convert the float to int, I told you right that since integer does not have any decimal values, it is going to truncate the fractional part, entire fractional part will be completely eliminated. Similarly, when I convert the double to float, so double is a value which is used to represent the decimal values and float is also used to represent the decimal values. But the precision of float is 6 and here it is something around 12, I think 15, let me say, or 10 sorry. Okay. So, this conversion it causes the rounding of digits. So, 10 precision will be converted to 6. So, the rounding off will take place. Similarly, in the third example, if I convert the long int to int, it makes the dropping of higher order bits. So, higher order bits in the sense the leftmost bits, these bits will be dropped. So, when these bits are dropped, the results what you are expecting will be some unexpected results. This is very important while you convert the higher order data types into lower order data types. Please keep it in mind. Careful conversion of higher order data types to lower order data types should be done. Right. So, by this we have completed the typecasting concept. Before ending our topic, let us go with one simple example of converting the higher order data types into lower order as well as the implicit typecasting also. Let us take an online compiler and then proceed. So, let me start with the hash include stdio.h, and I just want to convert the character to integer. My main function int main, and then I am taking an integer value, some int x is equal to some 10. I am taking a character variable char ch is equal to, let me take the character constant as small a. Now, what I want to do is, I want to take a variable some int y, and I want to add this x and ch. So, you may think that this is a wrong operation. Why? Because x is an integer value and ch is a character constant. So, while you make use of this addition operator on this integer and character, you may end up in an error. But what happens here is, the ch, we know the concept of ASCII values, right. So, the ASCII values are nothing but the binary the numerical equivalence for each and every character. So, the ASCII value of small a is 97. What happens when the compiler looks at this particular expression is, the ch, that is the lower order data type, look at this expression x plus ch. It consists of two operands, one is integer, the second one is char. So, the lower order operand ch will be automatically converted to integer. So, the equivalent numeric value of small a, that is lowercase a, is 97. So, what happens here is 97 plus 10 will be considered. Let me print out this value here. Let us check what is the result. See here, very simple concept. So, this is an example for implicit typecasting. You can give lot of examples, nothing wrong in it. This is an example program for implicit typecasting. So, the concept you have to understand here is, the character is converted to integer. Let us see what happens if I convert this, and I am storing, see here, the result x plus ch 107 is stored in an integer. Let us see what happens if you give the data type of float y as float. Sorry, here I write it as f. Okay. See here. See, in the entire expression, whatever I take here, ch is character, x is integer, and y is float. While taking the RHS of this expression or the equation, integer and character, the character is converted to integer, very good. And when you take the entire expression, the LHS when it is assigned to the RHS when it is assigned to a variable y which belongs to floating point data type, the lower order data type, that is integer, will be automatically converted to float. That is the reason why I get the value as 107.60. Very simple thing, right? For example, let me take another example where I want to take the double. Let me take two integer values, y is equal to 20. Now let me take this as x plus y. I am just removing this. Right. So here x and y are integer, and the LHS where you are storing the result is a double. So whatever result you will get will be automatically converted into long double. Let me take it. Double will have a format specifier as LF. Sorry. Double y sorry. Let me take this as z, this is z, and I want to print it as z. So the result is automatically, the integers will be automatically converted into double. Let me take the precision. Let me take an example of explicit typecasting, where I just want to forcibly convert one data type into another data type. Let me take these two values as double, and this is int. It's not 20. Let me take this value as 7. Y is equal to 3. X divided by y. So here x and y are double values and z is an integer value. Here what happens is, when you convert or when you type this particular, run this program, you will get the result as 2. That means the higher order data type, when you are assigning to the lower order data type, it is going to store only the values that are present before the decimal, and after the decimal they are completely terminated. This is what we have seen in the last slide. But when I want to maintain that particular decimal values, so I can make it as this as double or float, anything is possible, right? So here you can say it as LF, and this becomes, that means it will give the precision value also. See here 2.3333. You may have a doubt that the precision of double is 10 digits or 15 digits. Then why I am getting it only 6 digits, right? So we have some format specifier, like after this percentile you can specify the things like this. So if I specify it as percentile dot 15 LF, what does it specify? Means the output will be having 15 decimal places after the decimal point. This is what, let us see. See here 2.3333 and so on up to 15 decimal places will be there. For example, I want the precision up to only 7 digits. I can give it as percentile dot 7 LF. So I will get 2 after 2 there are 7 3s here, you can see here if you count it. Like this you can do it, but when we go for this explicit typecasting, I take these values as integer and double. So, x and y are taken as integer, the result I am storing it in double. Let me see what happens here. See here, you are taking the integer values and the end result you are storing it inside the double. So, the decimal points will be there, but the exact decimal values are not there. So, to correct this, that means you want to convert this x and y to be double. So, I can force the compiler that please convert this x into double like this. So, this particular double enclosed within this parenthesis is called as casting operator. This casting operator you can put it before this x or before this y also. Since you are putting this x before this double, the integer value x will be converted to double. Let us see what will be the result here. See, you are getting the correct result, 2.73s. So, this is an example of explicit typecasting where you are forcibly converting one data type into integer data type into double data type. So, this is a very good example on the explicit typecasting. We have seen the example on the implicit typecasting also, right. So, this is end of today's session where we have discussed the meaning of type conversion. We can also call the type conversion as typecasting. The definition of type conversion is C programming allows the conversion of one data type to another data type. So, this conversion can be done in two ways: automatic type conversion or explicit type conversion. Automatic type conversion is automatically done by the compiler, therefore, it is also called as the implicit type conversion, whereas the explicit type conversion converts, or the programmer has to force or request the compiler to convert one data type into another data type. We have gone through some of the very important points regarding this implicit typecasting as well as the explicit typecasting, and we have seen the examples, programming examples also. So, that is all for today's session on this type conversions. Thank you one and all for joining.